Tiziana, if my screen somehow works again. So Dr. Tiziana Ferrari is the director of the EGI Foundation. And since January 2018, she is also the project coordinator of the EOSC Hub, the EC-funded project bringing together many different national and international service providers and research infrastructures. Tiziana is well known for doing a long time these most important things in coordinating European infrastructures. And in fact, I just remember, I think the first ideas of EGI were circulated in 2003. So we are almost getting 20 years of EGI. I hope that we will have a wonderful party, of course. So Tiziana, I'm handing over to you, and we're looking forward to Scientific Computing 2021 to 2030. Let me see if you're still muted. Yeah, you're still muted, Tiziana. You have to unmute and then you can start.
Yes, thank you, Dieter. Thanks for the nice introduction, and hello, everyone. I see many friends in attendance, so it's a pleasure to be here. And thanks for this opportunity to talk about scientific computing in the past and in the future. I was asked by the program committee to keep an eye on collaboration and how Europe and Asia Pacific infrastructures that can increase the collaboration in the future. So with my presentation, I'm really bringing a different perspective on scientific computing, moving away from the problems of machine learning and software that Daniele presented, and giving a perspective of how international advanced computing infrastructures have been enablers of discoveries. So with my presentation, I will really walk you through the history, and as Dieter said, we have a history which is now around 16 years of production scientific infrastructure, and I will bring some information on how the EGI Federation, through the collaboration with Asia, has been supporting multiple disciplines. For those who don't know about the EGI Federation, it's a community effort bringing together major research data centers in Europe, but also internationally across all the continents, with the objective of pooling capacity, expertise, technical solutions, and bringing innovation for tackling data-driven science. Our mission as European infrastructure is to support international collaborations with closer ties and co-design. In fact, high energy physics is the let's say, starting point of the EGI Federation, has been one of the major communities bringing innovation in scientific computing, and we still benefit from close collaborations in many projects, as I will explain in a moment. This picture gives you a bird's-eye view of the EGI infrastructure today. We built on a long-term collaboration with Taiwan and many other Asia-Pacific countries that have been coordinated through our colleagues at ISGC. We have an MOU which is dated back to 2013. Today, the infrastructure brings together more than 1.3 million by research performing organizations and the national infrastructures, and more than 1 exabyte of data, primarily from energy physics, astronomy, and astrophysics research infrastructures. I'd like to give you a perspective on the current status of EGI as a membership organization. Our members represented in the country, in the Council of EGI, are today 26. We had 5 new members in the past 12 months, with Hungary joining, and 4 new international research collaborations in space science with ISGC Association, the EMSO infrastructure for the Mediterranean seafloor observation, ENIS, which is an international infrastructure for climate modeling, and CDataNet, international data infrastructure for marine science. These infrastructures are a core component of our council, and give you an idea of how important close collaboration of infrastructures and science is for international scientific collaborations. I'd like to explain how the federation is being possible. Firstly, thanks to the funding of our council members. We deliver, in collaboration with our international partners, the federating services, which are the glue to bring together computing and storage facilities, and having heterogeneous technical infrastructures and made accessible to scientific applications. One of the major areas of recent development is federated authentication and authorization, which is moving away from a traditional X509 based authentication, opening to new standards and mechanisms for credential management. But other areas of federation have been consolidating, and I'd like to mention, of course, security coordination, which has increased in importance and relevance given the large number of cyber attacks that infrastructures are subject to, but also accounting, collaboration tools, configuration management, help desk and coordinated support have been the glue for this international infrastructure. We have an increasing portfolio of collaborations with Asia. Next to the MOU that I've mentioned already, we had established recently a collaboration with the Shanghai Science and Technical Innovation Resource Center and with the Computer Network for Information of the Chinese Academy of Science, with the aim of broadening support to new research infrastructures that are in the scope of the Asia-Pacific region. The strong building block is experiments that have been already mentioned by Daniele, with Atlas, ALICE, CMS, BEL2, and ILC being the most established scientific collaborations, bringing together capacity from Asia-Pacific and Europe and the United States and Canada. These have produced more than 2,700 scientific papers alone, and a famous Nobel Prize, of course, for the discovery of the Higgs boson. But the landscape is evolving quickly, and today we can be proud of many other scientific collaborations that bring together Asia and European research organizations. And here I'd like to mention new production in facilities that are using distributed computing federated with EGI, ELI, the Dune, IceCube, and structural biology with ENMR, and next to these CTA. We're very proud of these collaborations, and of course these are the real engines for producing scientific discoveries with computing facilities federated with EGI. The largest majority of the capacity is still driven by energy physics, astronomy, and astrophysics, and the overall amount of resources contributed by these scientific collaborations amounts to 80% of the capacity. However, the user community is different. We have the majority of users coming from health and medicine, so 50% of the users today are from a different sector, and there is a growing group of scientific infrastructures that are now starting their operations in the area of environmental science, and this is a growing area of interest for both Asia and Europe. And this shows this, I hope this diagram shows how diverse is the portfolio of scientific collaborations, and how rich these scientific collaborations are when we bring together expertise and researchers. The expansion of EGI towards non-HAP disciplines has been fostered by many scientific projects. with different scientific domains, which in Europe have been supported by the European Commission and the Horizon 2020 research program. And this diagram shows how energy physics has been increasingly complemented by technical projects around artificial intelligence and machine learning, but also Earth observation, closer collaboration with policymakers that use research data for evidence-based policymaking, social sciences, proton and neutron sciences, and health medicine. I think we can be all proud of this variety, which makes scientific computing more and more accessible for data-driven science. This diagram shows the history and how the IGI Federation perspective has been evolving. There has been a steady increase by average plus 25% increase in usage, primarily driven in terms of volumes, of absolute volumes by energy physics, astronomy, and astrophysics. The High Throughput Computing Federation usage is the diagram on the left, and this diagram on the right shows the usage of a different platform operated in AGI, which is a federated cloud infrastructure, which today brings together 23 research cloud providers. And there's a specific and complementary facility. The largest user community is from environmental science, LifeWatch, but it's also multidisciplinary. The usage is being increasing thanks to the delivery of machine learning as a service, which is a kind of service which is in great demand in many, many disciplines, as explained by Daniele in the previous presentation. So we are very glad that this path-finding activity that started back in 2014, so it's recent compared to high-throughput computing, is now really proving its value to support new disciplines, and especially those that need interactive data analytics to manipulate their data. So this is a bit of an overview of the past, and with the remaining part of my presentation, I'd like to give a view of what are the future opportunities and challenges to increase our impact together towards science. We have been successful in establishing open infrastructures, sharing access to compute and storage facilities, and today we see many more experiments leveraging this heritage. But the challenge of the EGI and many other scientific computing infrastructures is to now evolve towards data-driven and scientific software-driven infrastructure. And I hope with my few slides to give you examples of how this has been possible and what are the challenges from a technical point of view related to that. So first of all, Europe is one of the largest producers of scientific applications in the world. We have been, as European collaborations, less successful in making this scientific software available internationally from many scientific disciplines which are less skilled digitally to reuse the scientific software as a service. This area has been actively explored by ISGC in Taiwan with the IGI Federation in the area of environmental science and disaster mitigation. So moving away from fundamental science to bring the research data to manage disaster, manage anthropogenic impact on environment. And environmental science is an area where sharing of data and scientific software can dramatically increase the time to publication. With science gateways delivering weather prediction tools and tsunami simulations, we are aiming to bring the best applications from Asia Pacific and make them available for use by European scientists by tapping into physical facilities and expanding with European capacity. In the area of health and medicine, I'm very proud to mention here a success story that is based on a long-term collaboration between Open Science Grid in the United States, EGI, and also a number of WSCG resource data centers In the last 12 months, we have been able to support thousands of drug simulations to discover how existing approved drugs can mitigate a series of COVID-19 symptoms. And here, again, the enabler of success has been the sharing of scientific software, in this case, a simulation software for modeling of drugs, and make them available internationally. The usage of resources has been doubling in the last 12 months. We have been able to scale up with resources beyond Europe. And with this diagram here shows how these scientific applications have been used internationally, where the largest user communities are in fact not in Europe, but in USA and India and China. This is an excellent example of open science. Open science means not just making data more accessible and findable and interoperable, but also making scientific publications open and the software open as well as a key enabler. And with this message, I'd like to fully support the message of Daniele Bonacorsi in emphasizing the relevance of scientific software for science. Today, this scientific long-tail community amounts to more than 21,000 users registered worldwide, of which just more than 4,000 are from India. And I hope with this, you can grasp the potential that these scientific tools bring to international collaborations and individual scientists. An area of future collaboration is, of course, being able to increase the access to these softwares across our continents and our research collaborations. And EGI is ready to bring the best of breed of European scientific software and to make it available internationally through collaborations. Another area of is technical innovation, and this means bringing new solutions to scientists that make their research workflow simpler and faster. Here, I'd like to mention 3 areas of innovation, technical innovation, that EGI is pushing for towards a number of scientific projects. Federated AI is a key enabler, but next to these compute continuum, which means cloud computing next to high throughput computing and high performance computing to support scientific workflows that require heterogeneous resources. And the majority of the communities existing today in EGI need these heterogeneous resources for their processing needs. And then the third area and challenge is making distributed data available internationally. Energy physics, which is distributed data and bring computing to the data, is still to be embraced by other scientific domains. And here I'd like to mention genomics, bioinformatics, and environmental science, that all require a large amount of data which cannot be anymore discovered and downloaded in a local lab or on the laptop. So more and more, the paradigm of distributed data access has to be embraced by new communities. And we also need the better and more versed solutions that are less dependent on specific computing models and are more generically applicable to different scientific domains. So these are areas of active exploration and innovation. This diagram shows how the overall software stack is evolving in the EGI Federation. We have been strong in developing a federated infrastructure as a service platform with research clouds, high throughput computing, but this platform has now to expand to public clouds for those that are tapping into commercially procured capacity and high performance computing. In Europe, the landscape is evolving. Next to EGI, we have a very important initiative that will bring high-performance computing at the exascale level available to science and other scientific domains. This is EuroHPC. But also Gaia-X is one of the major European initiatives with the industry that brings distributed computing as a paradigm for industry. And EGI is a member of Gaia-X since last year. So we are really looking forward at having collaborations with our HPC colleagues and industry to evolve our current federation paradigm. Key enablers for distributed data management are ESCAPE, which is a research cluster bringing together European infrastructures for energy physics, astronomy, and astrophysics. These are bringing innovation in scientific approaches to distributed data management and data lakes. We hope a lot of these developments will be made available as a general purpose solution to many scientific collaborations, and EGI is now partnering with STFC to deliver this solution for multiple VOs. But next to these also projects like ISGC Synergy and Indigo have been delivering platform as a service components and artificial intelligence as a service, which are now integrally part of the EGI software stack. Strategically, we are moving from an infrastructure federation to a federation which is complemented by platform as a service and software as a service, bringing also research data as an integral part of the infrastructure assets. So the paradigm that we're moving forward to is bringing data and scientific applications as integral and integrated elements of a federated infrastructure, which requires, of course, new technical solutions, but also stronger partnerships with the data providers in Europe, the ESFRI research infrastructures, and with academia for scientific software. The success story of this innovation, and here I'm showing federated cloud results, is that by having new mechanisms and solutions for scientific computing with cloud provisioning, for example, we have been able to support much better environmental sciences and health and medicine. So this is a great success, and I showed the usage trend before. But next to this, in a new flagship project that started in January called EGI ACE, which also involves Taiwan as a linked party in Asia Pacific, we are aiming at developing data spaces in different domains for energy and physical sciences, environmental sciences, humanities, health and medicines, and climate. This means having partnerships with data providers that, besides bringing their computing facilities, which is a traditional paradigm, they also bring their data as an integral element for third-party exploitation. I'm reaching the end of my presentation, and with this slide, I like to welcome partners from Asia Pacific to submit their use cases to a call that we have just opened, which will close on the 15th of April. To bring new scientific applications and data for distributed deployment. And we are open to any scientific collaboration which has international relevance. So I'd really like to welcome you to take a look at this call, and if relevant, to apply this will allow us to strengthen our collaboration with Asia, and particularly through the coordination of ISGC in Taiwan. So I'd like now to conclude and wrap up my presentation with a few conclusions. International collaborations in scientific computing have been key enablers for scientific excellence, and this has been possible thanks to human networks across the world, bringing coordinated support, training, and consultancy to scientific collaborations, but also thanks to agreements and shared access to compute and storage. There is a need now to have innovation and bring a new paradigm in scientific computing, with many opportunities also to broaden our spectrum of scientific domains towards health, medicine, and environmental science. Scientific computing has to move towards data-centric and scientific software-centric approaches, increasing the portfolio and the adding value services which are accessible. And we can do this by having closer collaboration and coordination with new user communities. And this is my call for, yes, working together to make scientific computing a success in the coming decade. Thank you.
Thank you, Tiziana. That was a wonderful talk. And again, I'll clap on behalf of all the 50 people which are on the call right now. Now, while the others are thinking about their questions, could you, I mean, you have also shown the other kind of comparable, maybe competitive approaches to all these things. What is the single most important characteristic of EGI? What would you say as the director is what makes EGI so special?
Well, the level of speciality in EGI is to being able to have the technology to federate data and computing at a larger scale. And this is the area of excellence of the EGI community.
And I think EGI is also much further than the others. Isn't it like what we see in EGI that others are still trying to catch up?
Well, we're very proud that thanks to our international collaborations, EGI can claim that in terms of geographical coverage and number of research data centers involved is the largest scientific computing distributed infrastructure in the world. So this is an area of excellence that we have achieved together. However, this is not sufficient. So the future will be being able to also bring capacity from other infrastructures. I've mentioned our HPC in Europe, but also peer infrastructures, and to break the walls we have been having historically between different initiatives in computing, and also making this more accessible internationally. So this is an area where EGI is really keen on collaborating with new emerging initiatives. Our HPC is very important, and our colleagues in the conference already mentioned also how Asia is moving in the same direction. So there is a great potential to make science faster by working together.
Yeah, and I think you get lots of credits for that, well deserved, because it's a tough endeavor to put all these things together, no?
Yeah, it's quite challenging in terms of policies, of course, and funding schemes, business models, and technology.
Thank you very much. Patrick Fuhrmann, I see you raised your hands.
Yeah, I did. Thanks, Tiziana, and good morning. And thank you very much for your presentation. I would like to refer to one of your slides where you are mentioning is the ESCAPE data lake. Mm-hmm. As you can imagine, as I'm mostly interested in data management. So as far as I can see, the ESCAPE data lake, it is more a prototype implementation and a proof of concept. It is not really an infrastructure they are building up. And however, I'm as coordinator of the Expanse project, I would be interested if EGI is considering to take this model and implement it with the help of its partners and make it available to or for the long tail of science, or if you would consider to leave it to them to actually build the system.
So what we are doing in collaboration with CERN and STFC is to deliver a number of data management solutions that are being prototyped in ESCAPE as solutions which are managed, so available as managed service to those communities that don't have the know-how and need technical support to run them. So yes, for solutions like FTS, Rusio, and other integrated components, STFC is and CERN are the partners bringing the technology, and STFC deploying it for multiple VOs as a managed service. So we are aware this is, of course, a moving target. So there is still a lot of testing, of customization, and many user communities, in fact, need bespoke solutions. But the idea is to make this more accessible as managed service through this
great, thank you. Super, thanks.
Patrick, any more questions? Otherwise, you have to put down your hand.
No more questions for now.
Okay.
Okay, thank you.
Great.